Hi friends, welcome back. Today we are going to solve another matrix related important coding interview question, minimum time to reach from source to destination. So this is quite interesting matrix problem. So we are going to go through this problem details with some examples so you can completely understand this problem, and we are also going to discuss the logic as well as the Java solution code to solve this problem. So this is an important coding problem from interview perspective. So make sure you watch this video until the end so you completely understand the logic as well as the Java solution to solve this problem. So before we start looking into the details of this problem with some examples, I would like to quickly mention that this channel is to help people in their coding and Java interviews. On this channel, you will find more than 500 different varieties of coding problems solved and explained using whiteboarding sessions, examples, and Java code for your easier understanding. All the problems come with Java solution code where the code is shared through GitHub repository. You will always find out the link to the GitHub repository code in all the videos description section. Among the solved coding problems, you will see all important coding questions varieties covered in them. That includes problems related to graphs, matrices, binary search trees, binary trees, breadth first search and depth first search related coding problems, problems related to strings, linked list, optimization problems, dynamic programming questions, as well as lots of logical coding interview problems are discussed with examples and explained with code for you on this channel. If you want to learn more data structures and algorithms and their applications in problem solving, then this channel is the best place. There are lots of important data structures related coding problems available for you on this channel. That includes problems related to stacks, queues, priority queues, hash table, hash map, reset, hash set, linked hash map, linked hash set, as well as many more important data structures related coding problems. So if you are preparing for any coding rounds of interviews or Java rounds of interviews, or you simply want to learn different concepts of computer science, programming, data structures, algorithms, problem solving, logic building, as well as Java programming and coding, then this channel can definitely help you in doing so. So please subscribe to this channel now. Whenever we come across any interesting and important coding problems or interview related coding challenges, we often create videos to help others also learn how to solve those problems and to help others also learn how to use different data structures and algorithms and Java programming to solve those different varieties of problems. So make sure you click on the bell notification icon right away so you won't miss any important postings from this channel. So let's start with the description for this problem: minimum time to reach from source to destination. Input 2D matrix is given to you. So this is what the matrix will have, right? So one means it is a source cell, 100 means it is a destination cell, 3 means it's a blocked cell, and 0 means it's a free cell, and 4 means it's a cell that constitute a bridge. Bridge can be formed by cells that are connected in 8 possible directions. It takes 1 minute to move between adjacent free cells connected in 4 possible directions, that is up, down, left and right. If you are on a bridge, it takes 1 minute to go from any cell on the bridge to any other cell. Find minimum minutes required if you start at source cell for you to reach to the destination cell. If it is not possible to reach to the destination cell, then print not possible. So this is what the problem statement says. So let's understand this. So with some examples we'll understand, so it will be more clear to you. So this one example is there. So this one is the source cell. So this is where we have to start basically, and 100 means it is a destination cell. So this is where we want to reach, right? And they are saying that if you are moving between these free cells, adjacent cells, there are 4 possible directions you can move, right? So 4 possible directions are, so for example, if you are here, right, so you can go to up, you can go down, you can go right, and you can go left. So these are the 4 possible directions you can move if it is a free cell basically, right? So you can go from here to here and here to here, right? 0 means free cell. From this 0 you can go here or here, right? From this, if you are at this 0, you can go here, here, here and here. So 4 directions you can move basically from free cell, right? Okay, so this is clear. So now what they are saying, another thing is, the 4 denotes a bridge, right? It constitutes a bridge and it can be formed by cells connected in 8 possible directions. So 8 possible directions means these are the 4 directions we just saw, right? So this is if the cell is a free cell, right? Then you can move in 4 directions. But if you are on a bridge, so this is a bridge, right? 4 is a bridge basically. So you can move in 8 directions. So what are those 8 directions? 1, 2, 3, 4, 5, 6, 7 and 8. So these are the 8 directions you are allowed to move. So obviously you cannot go outside of the boundary of the matrix, right? So these are the 8 possible cells that you can move. So if you are on a bridge, let's say you are here, right? Then you can go to this cell for this 4, 4, 4, right? So they are saying that once you are here, then you can directly go from here to here in 1 minute, right? Any place you can go on this bridge in 1 minute basically, right? This is what they are saying. So this takes 1 minute. So they are asking us to find out how much minimum time will be taken to reach from source to destination, right? So this is what they are asking. So this is the source, right? This is the destination, and we want to find out minimum time. So let's take a look at this example, right? So minimum time will be taken as 6, output is 6. So how it will take 6? So from this one we can go to 0, from this 0 we can go to 4, right? So this one takes, so from this 1 to 0 it takes 1 minute, right? Let's say this is a minute, right? So 1 minute from 1 to 0. Then from this 0 to 4 it will take us 1 more minute. So now it took 2 minutes, right? Once you are on this 4, then you can go on this bridge. This is a bridge basically, right? Because everything is 4. So 4s are bridges, right? So it can you can go in any 8 directions. So you can go like this. So you can reach to this 4 in 1 minute. Okay. So this is third minute. Okay. So in 3 minutes you are here. So from here to here it will take you 1 more minute. So 4 minutes are gone. From here to here it will take you sorry, here to here it will take you um, so this is sorry, so this is 1 minute, right? So this is second minute, and this is third minute, this is fourth minute, this is fifth minute, and this is sixth minute, right? So total minutes will be taken as 6 minutes. So this bridge means it is connected. You can go, once you are here you can directly go here basically, right? In that 1 minute only you will go from here to here. So it will be taking, once you reach this 4, then it basically you can move to any uh, from this 4 to 4 anywhere basically, it means, right? In that minute only, so it won't take any extra minute basically. Okay, so this is 1 minute, this is second minute, it will take you here, and this is third minute, fourth minute, fifth minute, and sixth minute. So in 6 minutes you will reach to 100, right? So this is what they are saying. So when you are, what they are saying basically is, when you are at a bridge you can go from this to this place within that minute only. So it won't take you any extra time because it is connected. So this point will directly take you to this point, right? That's what they are saying. So this is there is another example to take a look here. So let's look with this example, right? So now for example, this is, there are two bridges in this example, as you can see, right? This is one bridge 4 and this is another bridge with 4. So once you reach this cell, you can directly connect to this cell basically, since it is connected through bridge, right? So it won't take you any time basically, it's a part of the bridge, right? When you connect to this cell, it will take you from this cell like this, right? So you will directly reach here basically because it's part of the bridge. Okay, so it is part of the bridge, so you will directly reach here. Okay, so after this, so for example, the minimum time in this case is, this is again your source is 1, this is your destination, right? Now how much minimum time it will take? From here 1 to 0 it will take you 1 minute, from 0 to 4 it will take you 2 minutes. From this 4 you can directly go to this 4, right? So from this 4 you can go to all this bridge, you can go here directly in that minute only. So it won't take you any time basically, it is connected. Okay, so 0 to 4 only will take you 1 minute. From this 4 to this 4 won't take you any time because it is part of the bridge. Okay, that's what they are actually saying. And from this 4 it will be again 1 more minute to this 0, so 3 minutes, and from this 0 to 100 it is another minute, so it will take you 4 minutes to reach from source to destination. right? So this is the minimum time basically it will take you to reach from source to destination. This bridge if you use, it will take you more time, right? Because 1, then 2, then 3, then 4, and it will take you here, then 5, then 6, then 7, then 8, then 9, then 10. So it will take you 10 minutes, which is more, right? So we have to find out the smallest amount of time that will take you from source to destination, right? And if there is possible that there can be cells which are denoted by 3, so 3 means that that cell is a blocked cell, right? 3 means that the cell is a blocked cell, correct? So 3 is a blocked cell, 0 is a free cell, and 4 is a part of a bridge. So once you reach that 4 cell, it will be connected through the bridge basically. Okay, so you can go from any place to any place basically within that bridge without spending any time, right? Like this. So this is what the problem statement says. So now how can we solve this coding problem? So now the problem is clear to you, right? So this is the case where you have blocked cell, right? So this blocked cell you cannot go basically. 3 cells you cannot go, it's blocked, right? So you can go through cell 0, you can go to cell 4, and then you can go to any place from 4. It is connected bridge, right? So that's what they are saying. So now what we will do to solve this problem is we will use BFS, right? We will use BFS, which also stands for breadth first search or breadth first traversal, and it is also called as level order traversal. BFS is very useful to solve these kind of matrix related problems when you want to find out shortest path, minimum distance, minimum time. So these are the important things you should remember, right? So for those kind of questions, BFS is very useful. And why BFS works for these cases is because BFS goes level by level, correct? That's why BFS will reach from source to destination in minimum number of times, or minimum number of steps, or minimum number of distance, those kind of things, right? So we'll use BFS here. BFS uses Q. So Q, we will also use Q when we implement the code, right? So what we will do when we are solving this problem is, we'll first we want to do is we have to find out where 1 is in this matrix. 1 can be anywhere. 1 is the starting point for us, right? This is the starting point. So we have to find where 1 is. And for example, this is the case where 1 is. So in this case, so let's just move this matrix a little bit there so I can write down here quickly. So let's put it here. Okay, so our 0 0 cell is the source cell basically, correct? 0 0 cell is the source cell. So we'll be using BFS, right? And we'll create a queue, and we will put the cell which is a 0 0 cell here, right? 0 0 is the cell which is our starting point, which is the source. So we'll put the coordinate of that cell in the queue, right? Which is row and column of the location. This is 0 0. So we'll put this, and then we will go in 4 directions, right? We'll go in 4 directions as I shown you before, right? And whatever cells are actually valid cells, valid means what? Those cells should be 0, they should be free, or they should be 4, right? Or and most important, they should be inside the matrix, right? It cannot go outside the matrix, right? For example, from this one we cannot go up, right? We cannot go left because it will go outside the matrix. So we can go to right, we can go to down, right? So if we go to, so we'll remove this 0 0, we'll go in 4 directions, so it will take you to 0 1. If we go to the right, or if you go to down, then it will take you to 1 0, right? So you will again add these cells into the queue. Next time again you remove these cells, again you go in all 4 possible directions, so you will go to this cell, right? 4. Okay, so this cell is what? 1 comma 1. So you will enter 1 comma 1 here, right? And whenever you find out a cell with 4, then you are finding a bridge, correct? You are finding a bridge. So you want to use that bridge basically, correct? So once you find this 4, you have to go in 8 possible directions so that you can actually try, you want to reach farthest possible basically, right? So you wanted to reach to all these cells basically, correct? And this is the maximum cell that you will be able to reach. You will add this into the queue, and this is the cell that you will add, right? This cell is what? 0 1 2 3 4 5. So 5 comma 5. So this cell also you will add into the queue, right? So you already reached that 5,5 cell in that same level, right? In that same iteration of BFS. So it did not take you any extra time. Once you reach this 4, at that time you also reach this 4, because it is connected bridge basically. So you got this idea, right? So once you reach this 4, you also reached this 4 because it is part of a connected bridge. Okay, so you add this cell also into this queue. Next time you will start removing these cells. When you remove 5,5, you will again go in all the 4 possible directions here, right? Then you will reach here, then you will reach here, then you will reach here, and then you will reach here, correct? So this way you will be able to reach there very fast because of the bridge. So it only will take you 6 minutes to reach there, right? So 1, 2, then 3, 4, 5, and 6, right? So 6 minutes it will take you to reach there. Once you hit this 100, you actually found out the target, and you will just calculate the number of steps actually it took us to reach there, right? So each BFS iteration is one step, right? So one iteration, right? One iteration of BFS, one iteration is equal to one step basically for us, or it is equal to 1 minute for us, right? You can also say it is 1 minute. So it is just the same thing basically, right? So so this is the way you can find out the minimum time required to reach from source to destination. If we never will be able to reach this 100, then we will just print not possible, right? In that case. So this is the way you can solve this coding problem. So what is the case when it is not possible? For example, let's take a look at one case when it will not be possible. Let's say this 0, instead of 0 it is 3 here, and this is also 3. Then you just will never be able to reach here now, right? If this is 3, this is 3, this is 3, for example, right? Because it is not possible now to reach to this cell. So it is the case where it will not be possible to reach from source to destination, right? Because all these surrounding cells are blocked. These surrounding cells are blocked actually. So that's why you will not be able to reach to this destination, right? So this is the way we'll use BFS and the queue approach. And whenever we find out a bridge, we will start going in 8 directions. We want to actually cover all the cells which are part of the bridge. Similarly, in this case you will go from 1 to 0, and from 0 to 4 now you are at a bridge, right? Once you hit this 4, it means that all these 4s will be reachable. All these 4s that I am showing you are reachable directly, so everything will be added into the queue for all these 4s, right? So it will take you 1 minute here, from 2 minutes to reach here. So this won't take any time because this is part of the bridge. So you are reached here in 2 minutes. From here to here it is 3 minutes. From here to here it is 4 minutes total, right? So this is how you will implement the code. So I'll show you the code now, so it will be more clear for you. So this matrix is given to us, right? This matrix is given to us. So we'll just call our find path method here. So we have couple of variables here. So R is just just to show you, it is just like a 8 by 8 matrix here, right? So right now it is 8 by 8 matrix. So row is 8, columns are 8, steps is equal to actually number of minutes that will be required basically, right? So it is 0 in the beginning. These are the 4 directions which are up, down, left and right, and I showed you the 8 directions, right? So these are the 8 directions. So we'll use this 4 directions and 8 directions. When we want to go in 4 directions, we'll use 4 directions array, and when we want to go in 8 directions, we'll use this 8 directions array, right? So this is just a way to write a simple and clean code to use this array. So this is our main method, find path, right? It returns boolean, it finds the path and it tells if it is possible to reach from source to destination or not. And this int grid is given to us, right, which is a 2D grid, just like this basically. It's just like this, right? A 2D grid. So this is given to us. So we'll first create a queue, right? Queue will hold cell. So this cell class is we have defined here. So cell is a abstraction, right? Because every matrix cell it needs two things. It needs a row and it needs column. So ij is a row and I is a row and j is column. So we just created a cell class that we will use. We'll start. So queue will be holding actually cell objects. Okay. This is just like object oriented coding. So now we'll start going through the given 2D grid, and we wanted to find out where is the starting position, where is the starting point or source point, right? So 1 is the source point. Whenever we find out grid of ij is equal to 1, it is a starting cell, so we will push that cell into the BFS queue, right, as you can see here, and then we'll break out, right? Means we found the starting point. So now we actually wanted to start looping basically in the BFS, right? So this is our starting point. So 0 0 is the starting point. We'll put it here into the queue. Now this is we'll create one variable size. Size is to hold the size of that level, right? Because how BFS works is BFS works level by level. So every iteration we want to find out how many cells are there in that level, and we want to process that many cells for that level, right? So that's why we will use this size variable. So this while loop is actually a place where our BFS starts, right? So until queue has something to process in it, we will start looping and in this while loop, right? So first thing we do in the BFS is we read the size of the queue. So this size will tell us how many cells we want to process for the current iteration of the BFS, right? Or current level of the BFS. Now this another while loop will start looping, and it will start processing those many cells, right? So while size minus minus greater than 0, so we are processing those many cells for that level, right? So we will poll means we will remove the cell from the queue. We'll call it as a current cell. So current cell dot I, we get it in I. Current cell dot j, will get it in j. So I is row and j is column of the current cell, right? Now we wanted to check the basic check, right? That we don't want to go outside of the grid or outside of the matrix. So I is less than 0, I is greater than equal to R. J is less than 0 or j is greater than equal to C. It means that you are going outside of the matrix, right? So we just wanted to continue. We will not process it because that is not a valid cell, right? So that is the basic check we will do. Now other basic check we want to do is grid of ij is equal to 3, means it is a blocked cell, right? So blocked, if it is a blocked cell, we cannot process it. So we'll again continue. If it is 100, it means that we actually reached the destination now. So we'll directly return true because we have reached the destination, right? Now after this, we will change our current cell that we have found to 3, right? So we actually basically, instead of maintaining another visit array, right, or visitor array or visitor set, this is to why we are changing it to 3, because once we visit that cell, once we process it, we don't want to reprocess that again, right? We don't want to revisit it again. So that's why we'll keep 3 here, right? So next time if we go there, it will just continue simply from here, right? So that's why we will change it to 3 once we process that cell, right? And after that, we want to go in 4 directions for the cell, right? We want to go in 4 directions for that cell. So we'll again, what we will do, we'll get the current cells row, current cells column, we'll add the direction 0 and direction 1 to it, right? So x and y will get. So we will get the coordinate of the new cell, right? So as I said, the 4 directions are these, right? So if it is a matrix, right, if you are at this cell, so this is a I comma j cell. So if you want to go up, what you will do, I minus 1 comma j, right? This is basically, it means that you are going up. If you want to go down, what you will do, I plus 1 comma j. So it means that you are going down in the matrix, right? If you want to go to the right, what you will do, I j plus 1, right? So you are going to the right. And if you want to go to the left, then what you will do, ij minus 1, correct? So this is what exactly we are doing here in that 4 directions, right? This is the same thing, because these 4 directions will go in 4 different directions. It will calculate the new row and new column. Now we wanted to first check that this is not going outside of the matrix, right? And if it is equal to 3, it means it is a blocked cell. Or if it is already if it is 1 means it is source cell, right? Then we don't want to process it, correct? If it is already, if it is going outside of the matrix, if it is 3 means blocked cell, or if it is 1 means we will not process it, right? Otherwise we will add this new cell into the queue so that it can be processed further through the BFS. And then we will check if this new cell that we are looking at, is it 4. 4 means that we actually are finding a bridge, right? 4 means that we are actually finding a bridge, checking if this cell is part of bridge, right? This is what we are checking here. So now if it is part of bridge, then we will again do the same thing. We'll mark it as a 3, which means that we have visited this cell, right? Because we don't want to again process it. Now we already have visited, so we'll mark it 3. We'll create one boolean flag which is true, and then what this while loop does is it will now start going in 8 possible directions, right? It will start going in 8 possible directions, because once you find out, let me just explain you. So once you find out this 4, right, you go to 1 to 0, then 0 to 4, right? You find out this 4, it means that you are actually part of a bridge now. So you want to process this whole bridge, you want to process, right? So this is what we are doing here, and these are the cells which are connected in 8 possible directions. You can go to down, or you can go in this direction, you can go to right. All those directions we will process through this 8 directions array. And these connections means, are we finding out any connection, correct? Because we want to process this until this point only. Once you reach this point, there is no connection afterwards, right? This is the end of the bridge basically. This is the end of the bridge, so you want to stop it here basically, correct? So this is why this flag will help us. Okay, so connections is 0 in the beginning. Whenever we find out a bridge valid bridge cell which is connected to the current bridge cell, then we will mark it into connections, right? So that we know that actually we are getting a valid bridge cell which is connected to the current bridge cell, right? This is important. So for example we are processing from here, right? 4, then we want to go to this, so we want to keep continue until we find out a valid cell, right, which is a bridge cell. 4 is a bridge cell, this is again a valid cell, it is a bridge cell. So we'll process it again, process it, right? Process it, right? At this point now we don't have anything which is a bridge cell, right? So we want to stop at this time basically, because we have processed this whole bridge. So this is what we will this flag will help us. If there is no connections, means we cannot process anything further, the connections will remain 0, flag will be false in that case. So it will break this while loop basically, right? So it means that we have processed the complete bridge, right? So you got it, right? So now these are the 8 possible directions. We will again do the same thing. We'll take x and y, and x plus direction 0, y plus direction 1 will give us new coordinate of the new cell, and we want to check if this is actually a valid bridge cell or not, right? So if it is going outside of the matrix, we will not process it, or if it is not 4, it should be 4, right? Then only we will process. If it is not 4, we will not process, we'll just continue to the next cell in this for loop. If everything is fine, we'll add this new cell, because it is a bridge cell which is connected to our original cell, right? Original bridge cell. We'll add it to the queue with new cell x1 y1, and next time this x will become x1, right? Y will become y1. This is important, I'll again explain you. Next time this x will become this x1, okay? Y will become this y1, right? Because it is we are in loop, right? That's why we have to update this x and y value to x1 and y1, and grid of x1 and y1 is equal to 5. So we actually are processing this cell x1 y1, so we'll mark it as a 5. So basically it should not be processed again, right? So we'll mark it as a 5 here, and we will increment connections, because we actually found out another connection, correct? That's why in the 8 possible directions, this connection we should find out. If we don't find any connections, it means that we are finished with the bridge, we have processed the complete bridge. Like this, when you reach this point, you have finished the bridge basically, right? This point. So at this point you have to stop processing the bridge, right? So this is what it is doing. Okay, so after that we will increment the step here, right? Step is step plus 1. Once you process one level of BFS, you will increment the step. Step will be to count number of minutes it will take you to reach from source to destination. Every BFS iteration is equal to one step is equal to 1 minute. Okay, so at the end, if we reach here, then it means that you cannot reach to the destination basically, right? So we'll just return false here. If you can reach to the destination, here is the place where you will be able to reach to the destination, so you will return true here, right? And once we come back here to our original call, we will just, if it is true, it means that you are able to reach to the destination, so you will print yes, and you will print number of steps as minutes, right? Otherwise you will print that it's not possible, right? So let's take this example. Let's make sure this gives us correct answer. So for this first test case, we have seen that we are expecting 6 as the answer. So let's take this code and make sure it gives us correct answer here. So we are getting 6, which is the correct answer, right, as I explained you. So we'll test another matrix also here. So let's take another matrix here. So this is another example, right, which we have seen here, right? So as you can see here, it takes us 1 minute, 2 minute here. This is part of a bridge, so we will just take no minute here. Then from here to here 3 minutes, and here to here 4 minutes. So total 4 minutes will be taken. This is the example now we are testing here. Okay, this is the same example, so let's test it out. So as you can see, minutes is equal to 4, so it took you 4 minutes to reach from source to destination, which is again a correct answer, right? Which is again a correct answer. If you have a 4 here, right? If you have a 4 here, then how much time it will take you? 3 minutes, right? Because from 1 to 4 it will take you 1 minute. From 4 you will directly go here, right? In 1 minute. Then 2 and 3. So let's try this out. So it take you 3 minutes, which is again a correct answer, right? Again a correct answer. If you have a bridge which actually goes all the way directly to the destination, how much time it will take you? Only 1 minute it will take you, like this, right? So let's test this out also. So there are two possibilities now. So now it should take us only 1 minute and 2 minutes, right? 2 minutes it should take you. Let's take it out, test it out. So 2 minutes is the correct answer, as you can see, right? So our code is working correctly, as I shown you with couple of examples. So I'm going to add this code into my GitHub project. I'll give you the link of this GitHub project, so that you can check out this code. You can create your own matrix and test out this code, and make sure you understand how the BFS solution works. If you like the Java solutions in the GitHub project, consider giving it a star on the GitHub project. That would be great. If you are new to this channel, there is a very important coding interview related playlist we have created for you here. It is called as Lead Code and Lead Code Solutions. We have created more than 250 most frequently asked very important coding problems explained and solved for you. Those are the questions that got asked by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, LinkedIn, Uber, Lyft, and many other big companies many times in their interviews. So those are very important coding interview problems there. Make sure you go through all those problems, understand the logic behind the solutions, and also understand how the Java solutions are implemented to solve those problems. If you go through those videos, you are going to learn a lot about data structures, algorithms, problem solving, logic building, Java programming and coding, and it will also help you learn how to approach and solve medium to difficult level coding problems and how to implement their solutions in Java. So you are going to learn a lot of new techniques of problem solving there. You are also going to learn a lot of Java programming and coding there. It will also help you learn what are the frequently used Java classes and APIs that we often need during the implementation of different concepts and different solutions. So make sure you check out those important videos there. The name of the playlist is Lead Code and Lean Code Solutions. If you want to practice more coding problems for your practicing as well as for your learning purpose, then there are 3 other major playlists for you here. The names of those playlists are Code Forces, CodeChef, AdCoder. Code Forces, CodeChef, AdCoder, all in all, more than 500 different problems are here to help you in your interview rounds. If you are a junior level developer, you are a fresher, or you are a Java developer, there are lots of important problems solved and explained, and interview related videos for you are available here. That includes problems related to frequently asked coding questions about Java interview questions in telephonic interview questions and how to answer them. Java design patterns, Java architecture, SQL programming questions where they will give you database tables, they will ask you to write SQL queries to find out different data. So we have created couple of videos to show it to the freshers and junior level developers what kind of SQL questions typically gets asked in the interviews. So they will also get more idea about what to prepare about SQL questions. There are also videos that discusses Unix interview questions. For example, Unix commands, Unix utilities, shell scripting questions all are here to help you in your interview rounds as well as for your learning process. If you like this video, if you find this video helpful, and if this video has helped you in understanding how to solve this important problem, minimum time to reach from source to destination using breadth first search or BFS or level order traversal using queues, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Subscription is very important because that is the way the videos can reach to many more people, so other people will also be able to learn from this channel. They will also be able to learn new techniques. They will also be able to learn more problem solving, data structures and algorithms. So if you like this video, then do subscribe to the channel, give it a like for this video, share this video with all your friends, so your friends will also be able to learn from this channel. They will also watch these videos and learn more Java programming, coding, data structures and algorithmic approaches. If you like the videos on this channel, if the videos on this channel are helping your learning process, you are learning new techniques on this channel, these videos are helping you in your interview preparation process, you are learning more data structures here, then don't forget to mention that by writing comment on these videos. Your comments are very valuable for us. That increases our motivation to create more quality content videos. So if these videos are useful and helpful for you, then do mention that into the comments. Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly, keep your learning process going on continuously. And thanks for watching this video.